Okay, hello everyone, and welcome to another session. In this session, things will be pretty straightforward. We'll cover yesterday's assignment, or the last session's assignment. We'll then look at another homework question, or another question, and finally finish again with a third homework question that you'll have to solve in order to correctly answer the attendance quiz problems. So, to begin, this is our first question. It's relatively straightforward. Irwin Textile Mills produces two types of cotton cloth, denim and corduroy. Corduroy is a heavier grade of cotton, so it requires 7.5 yards of raw cotton per yard. Denim requires 5 pounds of cotton per yard. A yard of corduroy requires 3.2 hours of processing time. A yard of denim requires 3.0 hours of processing time. Although the demand for denim is practically unlimited, the maximum demand for corduroy is 510 yards per month. The manufacturer has 6,500 pounds of cotton and 3,000 hours of processing time available each month. The manufacturer makes a profit of $2.25 per yard of denim and $3.10 per yard of corduroy. The manufacturer wants to know how many yards of each type of cloth to produce in order to maximize profit. So we have a situation where we are dealing with two choices: how much cotton to make and how much denim to make. The prices associated with each are given near the end of the question. So we have denim at $2.25 and corduroy at $3.10. We're going to reverse those numbers. The reason is because we're in a situation where corduroy is listed first every other time in the problem. Only at the very end, when the objective function information is given, is corduroy listed second. So what we'll do is our objective function becomes max z, because we're trying to maximize profit, equals 3.10x1 corduroy plus 2.25x2. Now, let's go back here. Next, we have to look at our constraints. Our first constraint is, we see in the first sentence, it says how much cotton to make each of the materials. So it's 7.5 pounds of raw cotton per yard. That's yards. That was a typo. 7.5 pounds of raw cotton per yard, and denim is 5 pounds of raw cotton per yard. So we have 7.5x1 plus 5x2, and that must be less than or equal to the 6,500 pounds of cotton we see later in the paragraph. So our first constraint is 7.5x1 plus 5x2 less than or equal to 6,500. Our second constraint is based on processing time. A yard of corduroy is 3.2 hours. So 3.2x1 plus 3.0x2 is less than or equal to 3,000, which is the total hours of processing time we have available each month. Our third and final constraint. We see the demand for denim is unlimited, so we have no restrictions. But the maximum demand for corduroy is 510 yards. So x1 is less than or equal to 510 yards. We cannot go above that. There is no demand. So we move on, and we see here, a mistake was made by me. So I'll correct that. 3.10. 2.25, and that was the mistake I made because they always listed corduroy first until the very last sentence where they gave us our objective function. So looking at our problem formulation, we see max z equals 3.10x1 plus 2.25x2, which are the prices for corduroy and denim respectively, subject to 7.5x1 plus 5x2 is less than or equal to 6,500, which is the total cotton we have available in the cotton for corduroy and denim. 3.2x1 plus 3.0x2 is less than or equal to 3,000. This is our hours for processing and how much it takes for denim and corduroy respectively. Finally, x1 is less than or equal to 510, which is our demand for corduroy. And that is limited while denim has no demand or no demand limitation, because demand is essentially unlimited. So once we have this, as always, we're going to go into Excel first this time. We open a new file and we'll call it our denim corduroy example. We'll elongate each of our columns. And list here our products, corduroy and denim. Now here we'll list our profit, and it's 3.10, 2.25. Then we have to list our restrictions. The first one is total cotton available. The next is total processing time available. And the final is demand for corduroy. We're going to come up here. This is where we'll calculate our actual usage of our resources. And again, what we have available right now. From the question, we saw that we had 6,500 yards of cotton, 3,000 hours for processing, and we have a maximum demand of 510 for corduroy. Coming over here, we have to enter our key information. Cotton is 7.5. Denim is 5. And that has to be less than or equal to the 6,500 we have available. Processing time is 3.2, 3.0, and it's less than or equal to the 3,000 we have available. Finally, demand for corduroy will here, in this situation, demand for corduroy, we make this 1 because we just have to represent corduroy, and it has to be less than or equal to 510. We're almost finished. We have to enter our products one more time because the computer needs to know what to run permutations of. And it's corduroy, denim. Finally, profit is what we are trying to ultimately determine. Now we have to enter our formulas. So profit is the corduroy, the price of corduroy times the amount of corduroy we produce, plus the profit per denim times the amount of denim we produce. We come over here one more time. To determine our usage of cotton, we have the amount of cotton per times the amount of corduroy we manufacture, plus the amount of cotton per denim times the amount of denim that we manufacture. Again, the processing time per corduroy times the amount of corduroy that we manufacture, plus the amount of time per denim times the amount of denim that we manufacture. Oh, no, I hit equal. We can see here that I hit equal twice. So that our formula was mistaken. So we change it again. Here, times the amount of corduroy, plus the processing time per denim, times the denim we manufacture. One more time, equals here, times the amount of corduroy. Now, all of our information has been entered correctly. All we have remaining to do now is to go up into our solver function. So data, solver. Our key information is found in not D10, but B15. We're trying to, oh, that became a problem. We have to erase D10, so that's B15. We're trying to not minimize, we're trying to maximize. The computer will experiment in these two cells, B12 and B13, because these are the unknowns. How much we will manufacture, we do not know yet. We're going to add our constraints. The first one, the total usage of cotton must be less than or equal to the total cotton available. D7 must be less than or equal to F7. We add that. The next one, our total usage of time, D8, must be less than or equal to the total time we have available, which is F8, 3000. And our final one, demand for corduroy, which is D9, must be less than or equal to the total corduroy demanded, which is 510 F9. We hit OK. We click on the Simplex LP, and very simply we hit solve. We're going to solver found a solution, meaning we found an answer. All constraints are obeyed, are satisfied, meaning we haven't broken any of our rules. And optimality is satisfied, meaning this is our optimal possible solution. So our optimal possible solution is to produce 510 yards of corduroy, 456 yards of denim, which will give us a profit of $2,600. We see up here that we're using only 6,105. This doesn't seem like our optimum solution, but it is very clear because we are using the maximum time. We have more cotton available, but we have no more time. If we had extra time, we could use more cotton, but because we're limited, this is our limiting constraint, the constraint that stops us from continuing. So we have leftover cotton quite simply because we do not have enough time to process it. So let's save this as our denim corduroy example and close our window. We open QM, module, linear programming, new file. We'll call it our denim corduroy example. We have two constraints, and we know that we have two variables and three constraints. We're also trying to minimize. This seems very easy, but if you make a mistake here, all of your answers will be incorrect. So always pay attention to this. We minimize and we hit OK. Now again, we don't have to label, but we do it anyways because we want everything to be clear. So corduroy denim. If corduroy is 310 and denim is 2.25. Our first constraint we see here is total cotton. Second constraint is total time. Third constraint is corduroy demand. So our total cotton is 7.5, as we saw before. 5 must be not greater than or equal to, but less than or equal to the 6,500 we have available. Total time is 3.2. 3, again, less than or equal to the 3,000 hours we have available. Finally, corduroy demand is less than or equal to the 510 that exists. So we've entered all of our information correctly. We hit solve. And something happened, so I'll edit my data now. We're trying to minimize our costs. These are our costs that exist. 7.5 less than or equal to 6,500. 3.23 is less than or equal to 3,000. X1 corduroy is less than or equal to 510. This is where we ran into problems. So total cotton, right now, all three of these are telling us less than or equal to, less than or equal to, less than or equal to. In this situation, why is this not working? We see very clearly that we've entered the data exactly the same as the last one. But if you'll remember, at the very beginning, I told you to be careful with minimize and maximize. If we are minimizing cost and everything is less than or equal to, the computer will manufacture 0. 0 minimizes our costs. We're not trying to, so I entered minimize to see what would happen. If we click maximize, so we're going to edit our data. We click maximize. Everything is exactly the same. Let's see what happens. In this situation, because now we know what's happening, we have to be below these, but we also want to maximize. That was the key. That is always the key. If we make any small mistakes, these things happen. So again, when we enter the data correctly and we choose the correct minimization or maximization, we get the exact same answer that we got in Excel. 510 yards of corduroy to manufacture, 456 yards of denim, which will maximize our profit at $2,607. All right, so let's save this file one more time, but I'm going to, okay, denim corduroy example. We click save. And we're going to close this file. So now we'll move on to our second problem. This is one more time a two-variable revisitation. Ruckelshaus Public Relations has been contracted to do a survey following the election in the USA. The firm must assign interviewers to conduct the survey by telephone or in person. One person can conduct 80 telephone interviews or 40 personal interviews in a single day. The following criteria have been established by the firm to ensure a representative survey. At least 3,000 interviews must be conducted. At least 1,000 interviews must be by telephone. At least 800 interviews must be personal. An interviewer conducts only one type of interview each day. The cost of $50 per day for a telephone interviewer and $70 per day for a personal interviewer. The firm wants to know the minimum number of interviewers to hire in order to minimize the total cost of the survey. So we see here $50 for telephone, $70 for a personal. That is our objective function. We're trying to minimize z. Again, be very careful with minimize and maximize. Min z equals 50x1 plus 70x2. That's our objective function. We continue on and we look. We see that one person can conduct 80 telephone interviews or 40 personal interviews in a single day. We can't split it up. That's important. At least 3,000 interviews must be conducted. So 80, which is the number of telephone interviews, plus 40, which is the number of personal interviews, must be greater than or equal to 3,000. The number of telephone, 80x1, plus the number of personal, 40x2, must be greater than or equal to 3,000, our first constraint. We see our second constraint, at least 1,000 interviews must be conducted by phone. We know phone is x1. So x1 must be greater than or equal to 1,000. x2 is personal interviews. So we know x2 must be greater than or equal to 800. So we have three very simple constraints in this problem. It should be relatively easy when you look at this to very quickly format the problems accordingly. So let's go over here. And we see that minimize z equals 50x1 plus 70x2, subject to 80x1 plus 40x2 is greater than or equal to 3,000. x1 is greater than or equal to 1,000. x2 is greater than or equal to 800. These are all greater than or equal to. If we were trying to maximize, the computer would continuously add numbers. It would be impossible to determine a correct solution because everything is greater than or equal to. It will just keep going higher. But it's a minimization. This is what we saw in our last problem. This is why I wanted to highlight it. If everything is greater than or equal to and we're maximizing, we're going to keep going forever. But because it's a minimization, we're going to go until we've reached these levels and stop immediately because we want to minimize our costs. So, without further ado, let's go down. Let's open up Excel and QM. First Excel. Open a new workbook. Lengthen our columns, and we'll call this the polling example. Our choices, our options, our telephone interview, personal interview. And we know our costs associated with each. Our telephone interview is $50. Our personal interview, $70. And then we have our resources here, our minimal requirements, we'll call them. The first one is total interviews. The second, telephone interviews. And the third, personal interviews. So we have now, we're going to come over here, and we'll call this our usage, because this is where we're going to calculate how many we conduct. and available. Required, we'll call it this time. So total interviews, we have 80 for a telephone, 40 for a personal, and we require must be greater than or equal to 3,000. Telephone interviews, X1 must be greater than or equal to 1,000. And personal interviews, X2 must be greater than or equal to 1,000. We're almost finished. As always, we have to list our options again. So telephone, personal. And we're trying to minimize our cost. So once all this has been done, we enter our formula. Our total cost is the cost for a telephone interview times the number of telephone interviews plus the cost for a personal interview times the number of personal interviews. Over here, usage is equal to number of total interviews times here times here equals this times the number of telephone equals this times the number of personal. And we've successfully completed all of the information required so far. So now, double check here. Okay. So now we come over here, and as always, click on Data, and go into our solver function. Our ultimate goal we find in cell, not D9, but B14. Max or min, in this situation, very importantly, choose minimization. We're changing the variable cells, meaning the information we do not know is how many personal and how many telephone to conduct. Simplex LP as always, and we're going to add our constraints. The first one is the total interviews must be not less than or equal to, but greater than or equal to 3,000. Add this. Telephone interviews, D7, must be greater than or equal to F9, 1,000. Oh, and I see right now that I've made a typing mistake. D8 must be greater than or equal to 800, but I wrote 1,000 here. So let's do 1,000 and see what happens. Okay, so we're going to click Solve. But knowing that it's 1,000, what's most likely going to happen is we'll still find an answer, but our answer is going to be higher than our optimal solution because our true optimal solution only requires 800 personal interviews. So the number will come down. We'll solve it twice anyways, just because. So we hit Solve. We found a condition, 1,000, 1,000, costing $120,000. But we know this is only 800. It's not actually 1,000. So we're going to do that. We'll click on Solver. All of our formulas remain identical, and we'll solve. And we see that now we click OK. And we see here that we have 1,000 telephone, 800 personal for $106,000. We'll save that as our polling example. And we'll move on to QM. So module, linear programming, We'll open a new file. We'll call it our polling example. We have 3 constraints as we saw, and we're trying to minimize our costs with 2 variables. We click OK. We lengthen these for simplicity, for comprehension. The first one is telephone, the second personal. Telephone is $50, personal is $70. Constraint number 1. We see here is total interviews. Telephone interviews. Personal interviews. All of them must be greater than or equal to, so we're okay. Very simply, 80, 40, 3,000. Oop. 1,000, 800 as we said. Oh, not 8,000, 800. So once all the information's been entered accordingly, we click solve, and we get exactly the same answer. 1,000 telephone interviews are conducted, 800 personal interviews are conducted, costing us $106,000. We'll save this as polling example. And we can close the program. So the last thing today, as always, is I'll leave you with this homework problem, question number 6. I'll maximize here, and I'll address the class at the 40-minute mark. This does not have to be submitted as always, but as always, you do have to complete it if you want to successfully complete our attendance quiz. So good luck. If you have questions, please contact me through Kakao. I'll leave this here and address the class in 8 minutes. Thank you as always for listening. All right, everyone. If you have questions, as always, contact me through Kakao. Hopefully there are none. Hopefully everybody's following along. And please complete your assignment before the end of class. See you next session.